In this mini project, we'll be building a conversational chatbot. And our chatbot can get weather information from a third-party service and return it back to the user at request. So after that, we will integrate that chatbot into an Angular application. Right. Some of you guys might wonder why would we even need a conversational chatbot in the first place? Well, in modern web application, user experience is one of the most important thing, I would say. Let's say that you have a website with really great services, but your users are rather non-technical users. So they find it really difficult to use those complex interfaces to get your services. Or maybe your users cannot use mouse or touchpad due to their activities that they are involved in. For example, there could be drivers who's using your application and they find it really difficult to use mouse or touchpad, I believe. So in those cases, wouldn't it be nice to have a different interface where your users can use natural language or their common day-to-day speaking language to consume your services? So that would be really a handy thing. So that's where a conversational chatbot comes into the play. Since you guys have been staring at the diagram for a while, so let's quickly go through it. So we are going to create a conversational chatbot using Amazon Lex. So our chatbot will return weather information when a user asks for it. For example, our users might say, get me weather in London today, right? So that particular occurrence will be received by Amazon Lex. And it will check if that utterance matches with the defined intent in Amazon Lex, and if so, it will trigger a Lambda function which will call a third-party API and return it back to the user a relevant weather information. Now remember those terms: utterances, uses utterances, and Lex matches if utterances to a intent. If it is matching, it will call a Lambda function to talk to a third-party API to fulfill his request. So those terms will get into that in more details when we do the demo right about now. Okay, now let's go into the AWS console and find AWS LEX. I will go to services and let me type LEX. Here we have. I will select it. So if you haven't created AWS LEX chatbot before, this will be the page that you'll be directed to. Select Get Started. So in the next page, AWS will give you some sample bots to try out. These ones. And also, I have noted that there are some terminologies that we need to be familiar with, such as intent, utterance slots, prompt, and fulfillment. So intent is particularly goal the user want to achieve. So in our case, our user's intention is to get weather information of a particular city. So what we will do is we'll create an intent called finding weather and attach some sample utterances. So if our users utter something similar to those sample utterances, it will trigger this particular intent. So let's see that in action in a bit. I will go through these other terms when building the application. But first, let's select custom bot and give it a name. I will call it weatherbot. Output voice, we'll select it none because this is only a text-based application. Of course, you can attach some voice with Amazon Polly. Session timeout, will have it as 5 minutes. And AWS has assigned an automatic role for us. Keep it as it is. And for COPA, just select no because you're not keeping any privacy information about children, right? And then click create. Okay, now first call to action button is create intent. So like I mentioned, let's create intent called finding weather. Let me say finding weather, like finding Nemo, and click add. All right, now the next task is to define some utterances. Now remember that users don't have to utter exactly these phrases, but thanks to Lex natural language understanding capabilities, any similar phrases that we listed here will be matched to this intent. So since our application is getting some weather of a particular city, a user might ask, tell me about the weather today. I will add that. So you can add other utterances as well. Okay, now in order to fetch weather, we need some required information, such as the city. From the user, we haven't yet received it. So in order to receive that, we need to prompt user to tell the city name. So that's why the slots are here. So in the slots, we have this prompt. So let's give it a prompt called, I will say, sure, which city? So when the user answers this, for example, if he can say London, so that information we will save it in a variable called city, and this variable is type of a city. So our Lex bot will find it easy to match those city names. So we'll give it a name or rather a city type, slot type as Amazon Great Britain City. Okay, let's add it now. Okay, great. So now when the user say, tell me about the weather today, our bot will reply, sure, which city? Then he will respond it back with the city's name, and he will have that city name stored in a variable called city. Now there could be situation the user will directly give the city name when they are asking the question. For example, he might say, how is the weather in London? Or else it could be any city. So in order to define any city, we can simply replace our variable name here. And when we add this, you can see it has highlighted city. So it will match the slot value with whatever the variable city name that the user is asking for. So now that we have the city, the bot will not ask this question because it already has got the city name from the question itself. So let's add another utterance. Let's say, what is the weather like in their city name? So this is another way the user can ask for weather information. All right, so first two cases, the second prompt will not be asked. For the third utterance where the city name is not defined, the bot will ask this question and get the city name and store it into the slot. Great. Now we have everything we needed to get weather information from the user's end. Now we need to hook up a Lambda so that our Lambda can fetch data from the Open Weather Map API and send it back to the user as a response. But in this part, we are not going to create a Lambda. We'll do it in the next part. We need to test this bot right now. So in order to test that, we'll add a mock message. So instead of setting the fulfillment as AWS Lambda function, I will set it as return parameters to users. And then in the response block, I will add a message and I will say temperature in whatever the city name that they have given is, let's say, 25 degrees Celsius and humidity level is 55%. All right, so let's add that and afterwards save the intent. Nice. Then we have to test it. Now AWS LEX dashboard itself, we can do the testing part. We don't have to attach it to a website. So in order to test that on the console, we can first build the bot. So when building it, AWS LEX will train our bot to answer for these questions. We'll give it a second to build it and afterwards we can test that. Okay, now it is successfully built. If I close this message, you will see the right side panel is open. So I can chat with my bot. So let's say, tell me about weather today. You see, since I have not specified the city, it will ask me the prompt. Which city? I will say London. Yeah, so it captures the city name into a city variable. So if you look at the slot section, you will see it has filled the city variable with the name London, and then it has returned my final response, the message. Temperature in London is 25 degrees and humidity is 55%. We created a bot using Amazon Lex and we tested out on AWS console. So we still are not communicating with the actual API. So in this part, we are going to hook up a Lambda that actually talk to an open weather map API and get the actual weather information. So let's start creating a Lambda function that will be invoked by Amazon Lex to get weather information. So for good measures, I will be using serverless framework. So in the previous videos, I've mentioned how to install this serverless framework. So if you visit this link, you will be easily follow these steps and get it installed. Now I will go into my terminal and let's see where am I. I will go into my desktop. I will create a folder, Chatbot, and I will cd into that particular folder. Now let's create a serverless service. So in order to create a serverless service, we are going to use this particular command. Serverless create -- template AWS Node.js -- path. The name of my service, we'll call it mybot. Now it will create a template, AWS Node.js template. So I can start building my serverless function or Lambda function. Okay, if I do a listing, you will see my service name appearing there. So I will go into that my bot folder and I will open it in Visual Studio Code. All right. Now as you can see, there are three files. Serverless.yml is the configuration file. So let's clear out this clutter. I will take out all these comments. Right. When you remove the comment, you'll see only a couple of lines of code here. So first, we can give a name to our Lambda function. So the default one is hello. We will change it to get weather because that's what our function's main task. So I will add the same name to our handler function as well. Save it. And if you go to handler.js, you will see it has some boilerplate code. Instead of this hello function, I will rename back to the get weather function and I will take out this code. Or in fact, I will take out all this code. Because the previous code is relevant if we are invoking this Lambda function through an API. But now we are allowing AWS Lex to call this Lambda function. So there's a certain structure of JSON that needed to be written so that AWS Lex will understand the response coming from the Lambda function. Now I want you to go to this particular repository. Let me take a web window. And if you go to this particular repository, github.com/mjson/webweatherbot, you will see there's this Lambda function folder. If you go into that, you can see those files and go into the handler.js file and let's copy in the code. I will copy it and I will go back to my Visual Studio Code and I will paste it in. Okay, now that I have pasted in the code, you will see that we are requiring a dependency called Axios. So this particular library helps us to send an API request to our Open Weather Map API and get the weather information for a particular city. Now let's go through this code and I want you to focus on this return function. So in this return object, As you can see, there's a certain structure. So it has a session attribute, dialog action, and there are some other attributes as well. Now this is a required structure where the AWS LEX can understand it. So we have to make sure we are returning the information in this particular structure. So what is a dialog action? Now there are different types of actions our AWS LEX can respond to. Note that the type of the dialog action is close. This means LEX does not expect a reply from the user. So once this response is sent to the user, he is not expecting any response back from the user. So it's closing the conversation. And the fulfillment state is fulfilled. And this is where we will send the message. So we will add the type to plain text, and whatever the message that will be shown to the user will be added here. Now, if you can see, we are constructing this variable up here. If I scroll it a little bit up, you will see we are sending an API call using Axios library to a certain URL. And this particular get URL is expecting a city name. Now, let's go to the browser and I will take you to the Open Weather Maps API section. You can sign up to this Open Weather Map and they will provide you some free API keys, or you can create some free API keys with some limitation. Now I have signed in and I've created a couple of API keys. So in order to use these API keys, you can just simply look into their API documentation. Click on API documentation, and there if you scroll it a little bit down, you will see API documentation section. And here current weather data, you can get it by the city name. Just select that. Right, as you can see here, so this is the URL pattern. You have to say api.openweathermap.org/data 2.5 weather. Then we have a query parameter Q, and it will accept a city name. Now, in order to actually get the data, we have to append the API key that I shown earlier. So let's get back to our Visual Studio Code. As you can see, this is the same pattern I'm using here. For the city name, I am passing in the city value that we have extracted from the user. So when AWS LEX calling this particular Lambda function, it will send that slot variable value into this Lambda function. We can extract it by its event object, event.currentIntent.slots, and there's this attribute city. Now it is corresponding to the variable that we have defined here, the slot value. So we can simply access that value and then pass that city into the query parameter that is expected from Open Weather Map API. And afterwards you can define the metrics or units. Here I have defined metrics, so I will get the temperature in Celsius, and this is the API ID. Right? So when we execute this, you will return the data, and from the data object you can extract the temperature information by data.main.temp and humidity information as well. And also OpenMap will give you a small description about the weather, so that one also we can extract. Okay. Now there are different other types of dialog actions. Now, as I previously mentioned, this is a closed type, so Lex is not expecting a response from the user, but there could be some other scenarios. There are other types like confirm intent, where the Lex is waiting for the user's response to call upon another intent. For example, let's say a user wants to travel to that particular city once they got to know about the temperature or the weather information. So he wants to know about the flight ticket price. So when that intent is called, get flight ticket price, the logic might need to get that city name again. But rather than asking it from the user again, you can pass that information or the city name in a session attributes. So that's why this particular array or the object is for. All right. So I think now the code is clear to you guys. So let me open up a terminal, and first I will install these dependencies because we have to make sure Axios is installed. npm I Axios. Okay, it's installed. Now let's use serverless to deploy our function. I will say SLS deploy, or you can say serverless deploy, and I will just hit enter. So at this point, make sure that you have configured your AWS credential with serverless. I think I misspelled it, so let me say SLS deploy again. Alright, so our function is now deployed. As you can see, the name is mybot/dev/getweather. Now let me just copy it, and I will go back to the Lex console, and I will refresh. Alright, so earlier we added the mock response. Now we need to call an Lambda function instead. I will select AWS Lambda function, and in the drop down we can search for that particular AWS Lambda function name. So just paste it in and you will see it appears down here. I will select it, and for the version I will select latest. Well, as soon as you select it, it will say we are adding some permission to the Lambda function, because if you can remember, when we are starting up the LexBot, it has assigned a particular role. So for that particular role, it will add another permission to invoke Lambda. I will say OK. Right? So make sure you select latest, and then let's save it, and we'll build the application or build the bot, and afterwards let's see if it really works. Okay, now the bot is successfully built, so let's close it up and we'll ask it a question. Tell me about the weather. So it will ask which city. I will say London. Okay, we got an error, so let's do a debug. So let me go into the Lambda function. So you can view the Lambda in the console if you click here. So that will open our Lambda code in the console. And let's try to debug. Well, as you can see, it will load the function code here. So it's still loading. And we have used async and await keywords, which is not supported on 6.10. So let's change it to node 8.110, which this is which async await is available, and this should be our issue. So let's save it and make sure if it works, and let's try it back. I will again ask, so let me try a different utterance. How is the weather in London? So this time it works. So it says the temperature is 14.9 degrees Celsius and the humidity is 77% and few cloud is expected. Awesome. So this is really nice, but I want to do one other adjustment. So for example, when this is embedded into a web application, a user might not directly ask about the weather. He will probably say hi. So at this moment, our bot is unable to recognize this particular utterance. It says, sorry, can you repeat that, please? So in order to make our bot more intelligent, so let's add another intent. We'll call it greet user. Greeting user. I will add it. Right. So what could be the sample utterances? Could be hi. It could be hello. Well, it could be like maybe howdy. Right. So when this is set, we can simply add a return parameters to But I want to make it more interesting. So we'll get the name of the user and give him a customized greeting. So when they say hello or hi, we would say, our bot would say, hi, what is your name? And we will have that name variable into a name variable, and we will set the type as name. Okay, and I will add it. So we have another slot variable called name. So when this is prompted, the name will be filled. So we can customize it. Hello, name. We'll say, how can I help you? That is much more customized. Or else we can say, hi, Manoj, or whatever the name. What do you want? Okay, we'll add these two as well. And I will save the intent and then build it again. And we'll wait until it is built. Okay, now the bot is built successfully. So let's try out one of these conversation starters. So you say hi. So this time instead of sorry, I didn't understand, it says hi, what is your name? So I will say Manoj and press enter. Then it will say hello Manoj, how can I help you? Now I can ask, tell me about the weather today. Then it will trigger the second intent, greeting you, finding weather. Then you will ask the next prompt, sure, which city? I will say Colombo. Yeah, so it has queried the API and sent me the current information in Colombo. The temperature is 30 degree and the humidity is 66 and scattered clouds is expected. I know it's the grammar wise it's wrong, but that's fine. So I believe right now we have a really nice flow of natural discussion. So our bot is ready to be embedded into a web application. Now let's integrate our bot with an Angular application. I will go to cli.angular.io and install Angular via npm. And here's the command to install it. I have already done that. Let's go to a terminal and let's make a directory. Okay, dir my Angular bot. I will go into the directory cd my Angular bot, clear the screen, and let's create a new application with an ng-new command. ng-new my bot, and I will add the Angular routing as well as I will set styles to be SCSS. Hit enter to install. Alright, until it is installing, let's go to our diagram. Now, in our web app, we are only allowing authenticated users to chat with our bot. So that's why we have added the Cognito into the picture. We are going to create a Cognito user pool and allow users to sign into the application. So when a user is signed in, Cognito will assign an IAM role to that particular user. So in that role, we are going to associate or attach an IAM policy which has permission to talk to Amazon LEX. Hence, our logged in user can talk with our chatbot. So at this moment, you might think this is a complicated task, but actually it is not. AWS team has done a tremendous improvement to their client-side JavaScript library, which is called AWS Amplify. Let me go to AWS Amplify website. If you go to aws-amplify.github.io or type in AWS Amplify into Google, you will go to this particular website. So we are going to use AWS Amplify and use their already built components for user authentication and LEX chatbot. Alright, so let's go back to our terminal and check if our application is installed. Yes, it seems installed. Let me do a listing and cd into my bot. Let me open it up in Visual Studio Code. Now, so in our application, we have our main app module, an app component. So we are going to add couple more components. Let me open up the integrated terminal. And I'm going to create a component called auth. So I will type ng-gc auth component. And also I'm going to create a component to have our bot. And I will call it home. ng-gc home. So inside the auth, we will have our login component, and in the home component, we'll have our bot interface. Right, if I go into the app folder, you will see the newly created two component folders. Alright, now let's go back to AWS Amplify page here, and I will go to Docs, JavaScript, and from here I will pick Angular. Now we need to follow along this instruction to make sure Amplify is added to our Angular application. So first and foremost, I need to install Amplify library via npm. So let me just copy in. I'll copy paste it and hit enter. Similarly, I will install the other npm library as well. Now it is a helper for Angular. I will paste the npm command to install AWS Amplify Angular library as well. Let's go back to our instructions. And the next step is to have aws-export.js configuration file. So we can easily add it with amplify init command. Now before that, you have to make sure you have installed Amplify and configured the Amplify CLI properly. You can do that by visiting this link. If you go here, you will see how to install Amplify globally, and afterward type amplify configure to add the keys. So let's get back to our Amplify instructions, and I will copy amplify init command and come back to my terminal, clear the screen, paste it in and hit enter. Now it is going to give me a prompt. So which editor? So I'm using Visual Studio Code. And what type of application am I building? It's a JavaScript and it is an Angular application. So our file directory source is in src folder, and distribution directory is, so you can type in the directory name that you have given it to that. And the build command ng run script build, and to start command it is ng serve. So we'll accept those default values there. It's going to ask whether to use an AWS profile. I will say yes, and I can just pick the profile. I will select my default profile, and afterward it start provisioning the project. So as you can see, it's running a CloudFormation stack. So it's creating the role, an S3 bucket, IAM role. Everything is necessary to create our application up and running on cloud. So that's it, it's done. So let's get back to our instructions page. And next we need to add authentication. So adding authentication is as simple as typing in this command, amplify add auth. So let's clear out the screen. I will type amplify -- help in order to see all the commands that Amplify is supported. And from here, you will see it has analytics, API, auth, function hosting, and bunch of services. So in here, I want to add auth service. So it's auth add. Then accept the default Yes, I will use the default configurations, and that's it. So at this point, it has added the configuration for a Cognito user pool, and it has associated it with a Cognito identity pool. So now we need to push our changes up onto the cloud. So that's very easy. So we can simply say amplify push. Now it is going to prompt me, is this correct? I say yes, because this is exactly what I want to push into the cloud authentication, and it is a Cognito resource. Okay, CloudFormation stack is complete. It should take a minute or so, so be patient there. So once it is complete, you should see AWS export.js file is created. Now this is the file that has all the configuration. So as you can see, it has the Cognito identity pool information and user pool information as well. Now we need to refer this configuration file within our Angular application so that we can talk to those services. Now I will go back to our Amplify instructions. We were here last time, and let's continue adding the rest of the configuration. In order to refer that AWS export file, we have to add these lines into main.ts file. I will just copy in the code main.ts, and there I'm going to paste in those 3 lines of command. So it's basically importing the Amplify library and getting the AWS export.js file. So it is in the same directory level. So it is just exporting it, importing it rather, and then it is configuring the Amplify library with that exported JSON file or JS file. Great. Now it is asking us to rename the AWS export.js to AWS export.ts file. We'll do that quickly. So let's take a copy and paste it in. So instead of AWS export 1.js, I will simply say AWS export.ts. So it can be correctly imported into the application. And afterwards, it's asking me to add this configuration into tsconfig.app.json. So I will go to source. I will select tsconfig.app.json. I'm going to add node as our compiler type. And after that, we have to import our Amplify Angular module and Amplify service into our main app module ts file. And I'm going to import AWS Amplify Angular library. And within that library, we can import these 2 functions, Amplify Angular module and Amplify service. So I will come back to our app.module.ts and import those 2 files, put it inside our imports, and Amplify service, I will put it inside our providers. That's all about the configuration. But since we are using Angular 6, we have to add a small polyfill. So if we scroll down a little bit, you should see Angular 6 support. And there it asks us to add this simple line of code into polyfill.ts. Let me just copy this code and go back to our code editor. And let me search for polyfill.ts. And in this file, I will add that line of code to the top of that file. Save it. All right, done. Now we are good to call our AWS services from our Angular application. Like for login and logout functionality, we are going to use the Amplify built-in component for AngularJS. So I will click Authenticator under Components. So if you can see, we have to add this component, this one, Amplify-Authenticator. I will just copy it and go back to my editor. So we are adding our login page into auth component. So I will go into auth component directory And I will open up auth component.html. So at the moment it has this default text. Let me just delete it and I will paste it in. Let me save it. And I'm going to use another built-in component for our LEX chatbot. So it is under components interactions. So let me just copy in this code in our editor. Inside our home component, I will replace the home component HTML with that. As you can see, it has few properties. So it has this bot name where we need to replace with our bot name, and these two commands, these two properties, I'm not going to use it. As for the bot name, we need to replace it with our bot name. Let's go to our Amazon Lex. So our bot is called weatherbot. Nice. Now if you look at our aws-export.js, you should see we don't have an entry for our interaction or the Lex bot. So we need to add this configuration into our configuration file because we are referring that configuration in main.ts file. As you can see, we are configuring Amplify with AWS export.js content. So we need to add that manually. So in order to add that, let's go back to our Amplify documentation, and under the Amplify interaction component, you will see the interaction documentation link. Let me just open it in a new tab, and there it has instructed us how to do it. So under the manual setup, you should see this is the way that we should configure our chatbot. Let me just copy in this code, and beneath amplify.configure line, I will just paste it in. So it's basically appending it to this particular Amplify configuration. So auth part we have already done that, so we need to just remove it, but interaction part will have it. So we'll call it weatherbot because that's the name of our bot, and I will replace the name again here, and the region is US East 1. That's it. Let's save the changes. So now we have the Amplify Authenticator at auth component where it will show the login screen, and once the user is logged in, he can visit home page and chat with our bot. Alright, I think we are good to go. Let me just open up our console again and clear the screen. Let's type amplify space serve to serve our application locally. So when it is serving the application locally, it will of course connect with our backend services. Now it is building our modules. If you can remember, we have given all these instructions when we are doing amplify init command. So we say, okay, how to build our project and also where is our dist folder. Now it says compile successfully. So now we should be able to go to localhost 4200 and view our application. I will go into browser and type in localhost 4200 and hit enter. You should see our main page. Now let me open up an inspect element, and I will just remove this default content. So I will go back to my code. I will go to app component.html. I will remove all the content above the router outlet configuration. Save it. Now it should remove this content. Great. Now as for the default route, I will go to app.routing.module.ts. I will add a new path here. If the path is login and redirected to our auth component, let me just import auth component. And also I'm going to add another path to our home component. I wonder why this IntelliSense is not working, but anyway, let me just copy in the part for home component here. Right. So it should be home component referencing here. Oops. Let me just copy in home component and edit here. Great. Now we'll add a redirection. If the path parameter is empty, redirect to login page. Now, of course, and if the path is not matching with any of the path defined above, redirect to auth component. Okay, that should be enough. Now let's go back to our bot, and you should see it is automatically redirected to login page. So in the login page, you might be wondering how this small login component or ugly looking login component is coming. So that is our authenticator component. So that is built into AWS Amplify. Of course, you can add styles to make it nice, but I'm not going to do that now. So first, let's create an account. I will click here and it will ask a username. I will type mjson and the password and also phone number, and I will click sign up. If we inspect the information or the API calls, you should see that this API call is sent to Cognito identity provider. So that will send an email to your email address with the authentication code. Yeah, I got that code. So let me just copy it in and let me click confirm. So you'll see there's a log confirm success. And now it's asking me to sign into the account. So username is already filled. Let me type in my password and hit sign in. You should see behind the scene it's connecting with the Cognito user pool and sign me in. Right. Now I didn't add any automatic URL redirection to home page, so I will type home path here in order to render our home component, and I get an error. It says the weather bot does not exist. So we got a typo here. So our bot name is correctly referred as weatherbot here, but in our main.ts file, under our interaction configuration, we call it different name. So let me just correct it and save it. And now if I go to the browser, it should render it correctly. Now I'm not sure if you guys can see it. So this is exactly that particular component. I know it's quite ugly. So we'll try to just chat with our bot. So let me say hi. This should be the send button. Let me click there. And we got an error again. And it is a 403 forbidden error. So if you can remember, earlier in the video I mentioned we have to do one step in order to make sure the communication happens without an issue from our web application to LexBot. So that is basically adding a permission to the logged in user's IAM role to talk with Amazon Lex. So we didn't do it yet. So that's what we are exactly going to do right now. So as I mentioned, since we are using Cognito, all the logged in users will be attached an IAM policy. You can view that. If you go to Cognito, I will just type in Cognito here. So in the Cognito service, I will select manage user pools. Well, I got many user pools. Well, it should be this one, I believe. Let's verify the user pool ID. It says 1_6 CVC. If I go to export.js and just verify it with the Cognito user pool ID on underscore 6 CVC, yes, this is the correct one. And here you can select federated identities link up here, and there you have to again select the Cognito identity pool ID. It is this one in my case, and I will select edit identity pool here, and this is my role. So let's go to IAM, Identity and Access Management, where we can add policies into that particular role. Let me go here and I will select roles, and let's find that role. It was my OT, yes, this one. So as you can see, I have authenticated role and unauthenticated role. For my unauthenticated users, I'm not going to allow them to chat with the bot, but only for authenticated users. So I go into auth role and I'm going to add a permission. I will select attach policy and let me search for LEX, LEX, and I will provide Amazon LEX full access. I will attach the policy. Now hopefully our application should be able to talk with our bot. So let's try it. I will type hi and hit enter. Well, awesome. Then it is replying me back, hi, what is your name? I will say Manoj and hit send. Hi Manoj, what do you want? I will say tell me about weather in Hastad. I will hit enter. Very nice. Now it is responding me the current weather in Hastad. Temperature is 14.93 centigrade and humidity is 59. Very nice, isn't it? You can add a little bit of styling here. I think I showed you the link to this repo earlier. If you go to github.com/mjson-weatherbot, and inside here you should see the website folder, and there go to source src and under styles.css SCSS, just copy in these styles. Well, trust me guys, even with this style it should look very bad, but let's add it and see. Anyway, I will go to style.css and let's see if it at least looks a little bit nice. Or is it worst? Right, let's type hi again. Now it has this little bit of colors. Hi, what is your name? Manoj. Hi Manoj, how can I help you? What is the weather like in London? Temperature 16.1 centigrade and humidity is 82%. And there's clear sky. Very nice. Alright guys, I think this is the end of this tutorial and also the end of this chatbot series. So I will see you in another episode. Thank you very much.